All right, so in this video, we're going to talk about the leading coefficient test. And this is all coming from the standard form equation of a polynomial function. So I would go back and look at your notes on number 2 on what the standard form is. And so over here, we have a leading coefficient who's positive for case number 1, right? And the degree n is even, okay? So the example I gave right here is x squared, right? You can clearly see that a polynomial of x squared right here, whose degree is even, right? This number right here is even, and leading coefficient right here is positive. What we're concerned about and what the leading coefficient test tells you is the m behavior of the function, okay? So the m behavior, if you just look at it, it simply rises on the left, and it rises on the right, okay? So that means any polynomial function whose degree is even, whose leading coefficient is positive, will always exhibit the same behavior. And the important thing to understand here is that on the AP pre-calculus exam, the limit notation is what they're going to use to describe this, okay? So instead of necessarily saying rise on the left or rise on the right, this is how they write it. So for rising on the left, what I can say is the limit as x approaches minus infinity. This just means x is going this direction right here, which is minus infinity. The y value, f of x, okay, remember the f of x represents the y value, goes to positive infinity. Okay, so that's how you say rise on the left. And then rise on the right, conversely, as x approaches positive infinity, right? This is positive infinity, whereas this is negative infinity. F of x, which refers to the y value, also goes to positive infinity. Okay, so this is how you describe rise on the left, and this is how you describe rise on the right using limit notation. Again, that's important because that's the notation that's going to be given to you on the pre-calc, or how it's written on the AP pre-calc exam. All right, so the next thing we're going to cover is case number 2. What if your leading coefficient is negative, right? You can clearly see that a sub n is less than 0. And, what's the m behavior if the leading coefficient is negative and the degree n is even? So in plain English, right, you could see that for negative x squared, right, it falls on the left and it falls on the right, okay? So again, right, the calculus or the pre-calculus notation using limit notation, as x approaches minus infinity on this graph right here, so I would write the limit as x approaches minus infinity, f of x approaches also minus infinity, okay? So that's how you write falls on the left. And then as x approaches positive infinity, right, going this direction, so I would write the limit as x approaches positive infinity, f of x also approaches, f of x is the y value, right? The y value goes down this way. F of x goes to minus infinity. Okay, so that's how you write falls on the left, falls on the right. Moving on to case number 3. So over here, if you have a leading coefficient that's positive and n is odd, right, the degree is odd, an example would be x cubed, right? And from the graph, you can observe that the m behavior, it falls on the left and it rises on the right. Okay, so again, in limit notation, you would write as x approaches minus infinity, the limit as x approaches minus infinity of f of x is equal to minus infinity. And then for rising on the right, you would write the limit as x approaches positive infinity, f of x approaches positive infinity as well. Okay, so that's how you write rise on the right. Okay, last but not least, case number 4. What if your leading coefficient is negative and your degree n is odd, right? That's just the reflection over the y-axis, or you could look at it as reflection over the x. In fact, that probably make more sense. But regardless, whether you reflect it over the x or y, this is what negative x cubed looks like. The end behavior rises on the left and falls on the right. Okay, so maybe you can pause this video and see if you can write the limit notation of rising on the left, falls on the right. All right, so this is how you write rise on the left as x approaches minus infinity. The limit of f of x, right? Again, f of x refers to the y value. The y value is going to positive infinity. And then for falls on the right, you would write the limit as x approaches positive infinity, f of x goes to minus infinity. All right, so that's a quick overview, or review in this case for some of you, on how you apply the leading coefficient test. It determines the end behavior. And again, the important thing to remember is that on the AP pre-calc exam, the limit notation will be used instead of this plain English rising on the left, falling on the right stuff. When you are graphing, it might just be simpler just to say rise on the left, fall on the right, or draw the arrows, but you really need to understand the limit notation, which we will cover in future lessons, so you'll get the hang of it.